This video is to remind you of the different topics that we covered when we learned about quadratics. This is just going to kind of hit the highlights. There was way more stuff that we talked about. However, these are kind of the main points here. The first example says, write an expression that is equivalent to x minus 2 times x plus 1. You guys can, since we've got these two groups being multiplied, this is where we FOIL or do the box method, that kind of a thing. If I remember correctly, most of y'all prefer the box method, so I'm going to go ahead and set it up. All right, here's going to be my box. I've got an x with a negative 2, and I've got an x with a positive 8. And then in the box, we multiply those. So in this box is going to be x squared. Negative 2 times x is going to be negative 2x. X times 8 is going to be 8x. And then negative 2 times 8 is going to be negative 16. All right, so I'm going to write those things out here. So I've got x squared minus 2x plus 8x minus 16. All right, we're going to combine our like terms in the middle, and we're going to get x squared plus 6x minus 16, right? And that's going to be our answer. Just to show you really quickly how you can check this in your calculator. All right, here we go. Okay, so in your calculator, right, you can go to your y equals and we can type in the original problem, right? So we can type in, let's see here, I've got x minus 2x plus 8. So x minus 2x, x minus 2x plus 8. All right, and then after my distribution was finished, I got x squared plus 6x minus 16. Okay, so just to check and see if we are correct, if these two things are equivalent, I like to go to my table, right? So second graph, and since all my numbers in my y columns are matching, I know that I am correct. Okay, so that's just a really quick and simple way for you to check and make sure that these are actually equivalent. Okay, all right, so we're going to go ahead and we're going to look at the next one. All right, example 2, simplify. And then we've got that x minus 5 squared, okay? Guys, when you've got this thing being squared right here, remember that it's x minus 5 times itself, okay? So the way that we're going to write this is we're going to write x minus 5, and we're going to multiply the exact same way that we just did. So again, I'm going to draw another box, okay? And we're going to do x times negative 5 and x times negative 5. Multiplying those numbers inside, we're going to get x squared and a minus 5x, and x times negative 5 is another minus 5x, and then negative 5 times negative 5 is a positive 25. So my red term is inside the box, x squared minus 5x plus 25. Combine your like terms, you've got x squared with a negative 10x, and then that positive 25. All right. Now, again, if y'all wanted to check your answers, just like example 1, I'm not going to do it again. You put this in y equals and this in y equals, and you just compare their tables. All right. I feel like that's probably the easiest way. On the right over here, we're asked to factor completely. Remember, factoring is the complete opposite of distribution. So we're trying to figure out where were the parentheses, right? What did we start with to end up here? The first thing we always check for, if you will recall, is our GCF. Do we have one? Well, 3 and 18 are both divisible by 3, right? That's the largest number that they're both divisible by. We've got an x squared and an x. So the most that both terms have in common is just x, all right? That's my greatest common factor. So that's going to be outside my parentheses here. To figure out what remains, remember, it's the opposite of distribution, so we're not multiplying, we're dividing. Right, the 3's cancel, x squared over x leaves me with just x by itself. And then we've got negative 18x over 3x, the x's cancel, and I've got a minus 6. Okay, so this right here is going to be my final answer. All right, now next thing we've got to look at, and by the way, sorry, you can also check this right here in the calculator, right? You can put this in y equals, and you can put this in y equals, and you can make sure that their tables are matching. All right, the next part I want to talk about is examples 4 and 5. All right, examples 4 and 5 are asking about roots, solutions, zeros, x-intercepts. If you guys will recall, remember that's talking about any time our graph is touching the x-axis, right? We're talking about those points right there. So this one says, what are the roots of the equation y equals x squared plus 6x plus 8? Well, you're supposed to know the factored form of this, right, is going to be y equals, and then we've got x times x, right, and then two numbers that multiply to 8 but add up to 6, that's going to be 2 and 4, and then you set them equal to 0 and all that stuff right there. Guys, I think that probably for now, it's going to be in your best interest to just put this in y equals in your calculator. All right, so we're going to put this in y equals in our calculator, and we're going to look and see our graph. Okay, so here's what that looks like. We're going to take our calculator here. Okay, oops, sorry. And we're going to clear everything out there from before, and we're going to type this equation in there right now. So we've got x squared plus 6x plus 8. Okay? And now I'm going to look at my graph. Now my graph is doing something random right now, so I'm just going to hit zoom 6, get it back to normal. Here we go. So you can see I've got two zeros. I've got a 0 right here and right here. Guys, those are my answers. My answers will be -2, -4. All right? -2 and -4 are going to be my answers. Okay? So, in my example here, I'm going to just draw a quick little sketch. I had 2 points over here, -2, -4. Those are my answers, right? Those are supposed to be points. We've got x equals -2 and x equals -4. Okay? On the right side of this thing, it says, what are the solutions to the equation? This is the same exact thing, they just ask it a different way. You might notice that it says it's equal to 0. Right? We always want it equal to 0. If it's equal to a number, right, on example 4, it just had a y equals, but on 5, if it's equal to a number, that number needs to be 0. All right, go ahead and put this in y equals. All right, and when you do that, you will get a graph that looks something like this. I'm going to type it in my y equals over here. I'm not going to show you because that takes a minute. I'm sure you can do it by yourself. All right, so I sketched this I looked at my calculator. I'm going to sketch it now for you. It looks like I've got one over here and over here, right? This is a -3. This is a +5. That's my answer. X is -3 and x equals +5. It does not get more complicated than that when it's talking about solutions. Okay, the next one tells us that we actually need to use the quadratic formula. So we're going to look at this. All right, and we're going to solve this using the quadratic formula, okay? So, first we identify a and b and c, right? You can tell that we're using them in the equation. So we've got a with x squared, right? A is going to be 2. B is the number with x, so b is going to be -7. And c is going to be this number on the end, the constant, so we've got -3, okay? So I'm using my numbers from my problem here. So x equals -b. All right, well, we just said b is -7, plus or minus the square root of, okay, b again, so -7 again, squared this time, minus 4 times a we said was 2, times c, which we just said was -3, okay? And this is all over 2 times a, which, sorry, we do know now is also 2. Okay, we're going to clean this up in pieces. I've got x equals -7, right? We know that -7 is just going to be a +7. Then we've got this plus or minus the square root of. I want to know what this number is in here. I don't want a decimal. I just want to know what this number inside is going to be, right? So we're going to calculate that. I'm just going to type those into my calculator here. All right, and I end up getting +73, and then underneath we got 2 times 2, so we know that is 4. If you look, 73 is not a perfect square. It's actually kind of an ugly decimal right here. So we're just going to leave this alone. We're going to call this good. All right, if it's not a perfect square, just leave your answer in this form. All right, last section in this video. Here we briefly about graphs of quadratics, just to remind you guys. If you want to sketch this graph, like if you wanted to look at it, y equals 3x squared plus 5, that's totally fine. It looks something like this. Well, that was bad. It looks something like this. Okay. So it says write an equation to make the graph translate 2 units down. Okay. If we're going to translate a graph 2 units down, we're changing this number right here, right? We're going to change this 5. So if we're changing this 5, we want it to go 2 units down, you literally just subtract 2, right? So y equals 3x squared instead of plus 5, right? 5 minus 2 is equal to 3, so we're going to do plus 3. All right. The next one wants us to take that same equation that we were given, and this time they want us to go ahead and make the graph narrower. All right. I don't know if you guys remember how to make these graphs narrower here, but all we got to do is change the a value, the number in the front. Okay, so now I'm messing with this 3 right here. So we're going to say y equals something x squared plus 5. Well, to make it narrower, that number in the front just needs to get bigger. It needs to grow faster. So any number 4 works, 5 works, 6, 7, 8, 9, 10. Anything bigger than 3 will work to make it narrower. Okay. All right, the next thing that we're going to look at is the question C, which asks us to translate 6 units up. All right, so again, we're talking about this number on the end. If it's talking about up or down, we're messing with C, right, the C value. So my new equation is going to be y equals 3x squared, right? We're going back to the original 3x squared, and this time it was at 5. Well, if I want to move it 6 units up, my new equation should be at 11, right, if we added 11 to that. And then last but not least, if we want to make the graph wider, right now, if we make it more narrow or wider, we're messing with the number in the front. And so we need to make it smaller, right? If it gets narrow when the number gets bigger, then it makes sense that to make it more narrow, we're going to make it smaller. So we're going to do 3x squared is where we started, right? So we need a number smaller than 3. So how about 2? Or 1, or a fraction, right? All those things would work. There are a variety of answers you could choose. All right, go ahead and get started on your quizzes.